on functions. Lesson 28. Functions and their inverses. This was one that was asked about a straight line. It said that the straight line is 2x plus 6 and that g was its inverse. So the moment that you start, you know that they are inverses of each other. First question, they wanted to know what is the y value of the coordinates of b. So b's coordinates is something that you can know from grade 8 and 9, that is your c value of mx plus c. So that would be 6. So on your sketch, you know that this is 6. That immediately implicates that this was also 6. I've put in a few many things here. So that this was also 6. Because remember, if they are inverses, the one's y-intercept is the other one's x-intercept. So they're asking me for that one. Next question, I was waiting for it. Get me the inverse equation. So what do you do with x and y? So it's going to be 2y plus 6. How do I need to write it? In the form y equal to, they will always say that. So you've got minus 2y equal to minus x plus 6, happiness. And then we need to divide that by negative 2. So if you divide negative 1 by negative 2, you get plus a half. And it's fine if you want to write x over 2. Normally we just write mx. X over 2 is also half x. And then divide by negative 2 is negative 3. And that was the question. Find it in the form. I like to write it so I can see it. That is then the inverse function g to the minus 1. So there's my equation. What does that minus 3 mean? That's the y-intercept of the red graph, which means that this is negative 3, which means that this is negative 3. The x-intercept of the original graph is the y-intercept of the inverse, because everything turns around. I didn't need that up to now. Then they also wanted me to find A's coordinates. You see it there's negative 6, but how do you get there? How do you find A?
You make them equal to each other.
Those are simultaneous equations. You've got this black one, and you've got this red equation. You need to put them equal to each other. So that'll be 2x plus 6 must be equal to half x minus 3, just for interesting sake. The fact that it's positive a half, the gradient, and positive to the gradient. Make sense?
Yes.
If you made a mistake and maybe got to a negative, you should have thought, has to be a positive gradient. Look at it. Okay? So then to solve that, there's a few things that you could do. You know that man likes to do LCD, so time everything with 2. If you didn't want to do that, that's fine. 2x minus a half x gives you 1.5 x, or 3 over 2x. And that is equal to negative 3, negative 6 is negative 9. Take your calculator and divide that by 1.5, or with your own brain, and find out that it was then minus 6. Now, how do I find the x? Substitute it back again. Let's do that, and then I'm going to show you something. In which one? Either in the black one, or in, let's not joke with the fraction. Agree? So it's going to be y equal to 2 times x. That was negative 6 and plus 6. That gives me negative 12 plus 6. That gives me
Negative 6.
Okay, so A's coordinates, let's answer the question. Negative 6, negative 6. But now let's think about this. The moment that you had negative 6 here, you could have known that the y value should have been negative 6. Why?
Because
They sit on the axis of symmetry. And the axis of symmetry is y equal to x. So everything on this, including that point A where they intersect, should have the same x and y. Just think about it. You were in so much stress that it took you like just half a minute to do that, so it's okay. But if you had thought about it and you got the x, you should have known whatever the one is, the other one should be the same. Because it sits on that line of symmetry where x and y are constantly the same. And you didn't have to show me this, you could have just said minus 6 and minus 6 if you had known that. Happy? Then they asked me for AB's distance. If I just say find AB, will you know that it's the distance? So find AB, that's the distance between A and B. Now I know that that is 6, and I've just been asked to find this. So to find the distance there, how would I do that?
Distance formula.
Analytical, in algebra. Okay? So I know that A is, and B's coordinates are?
6 and 6.
Be careful for 0 and 6. Okay, so the distance of AB with then B. Formula, on the formula sheet. Your best friend, the formula sheet. And we substitute, and we've got minus 6 minus 0, and minus 6 minus 6. So that gives me 36 and 144, which I don't need to know. You can just give me the calculator answer, which would be 180. Now your calculator wouldn't have said root 180, it would have said, please give it to me first in root form, 6, root 5, and then in decimals please.
13,42.
Units. Is it necessary that you write units? It's just nice and rounded off. Now, why would I go through all this trouble? Because I'm quite sure if this had been your matric paper and you left it at root 180, you would have gotten the full marks. But remember, in the beginning of the paper, they say, where necessary, round off to 2. So I'm feeling, let's just do it. Show it in all the different ways. This one, they would have specifically said, leave your answer in simplest third form. So I don't think that's necessary, but definitely, let's give it to them in 2 decimals, since the question said where necessary. So let's make sure we've covered all our bases. Last question says, find the area of triangle ABC. There isn't a triangle until I sketch it in there. Find the triangle ABC. Now if I have a look at that, do I have first instinct for area of a triangle is half base times perpendicular height, right? Is there a base and a perpendicular height here? Base, height, base. It doesn't look like it. But can I not split it up and have maybe the top one and the bottom one? Are you with me here? And get the 2 separately and then add them together. But still, can I work with half base times perpendicular height? For this GBC, what is the base and the height then?
Base 9.
Excellent. Do you see that the base is 9? That's the reason I wrote those in for you. And if you hadn't, you wouldn't have seen it. But then maybe if you didn't write it in, you would have thought, okay, well, I'll have to go for this one and get the x-intercept. I'll have to go for this one and get the y-intercept. And you would have gotten there maybe just 30 seconds longer. The base is 9. Happiness? And for that top one, what's the height?
6.
Alright, fantastic. For the bottom one, what's the base? Still 9. And the height? Just don't say negative 6. It's 6. Because the distance, remember how obtuse triangles work? If that's the base, where's the perpendicular height? It has to be outside here. That's the perpendicular height. And this height is from there to there, negative 6. But you can't say a distance is negative, it's 6. So this height is again 6. For no apparent other reason, but remember this thing is symmetrical, there's lots of other things to go with it, I assume. So let's look at triangle of area DBC. That'll be half base times perpendicular height. You said the base is 9 and the height is 6. Will give me 27. Square units. Do you agree with me? Because I'm busy with area. And then what's the area of the other triangle? The AC. Same thing. Half base times perpendicular height. Will give me half of 9 again and 6 again. Remember that it mustn't be negative 6. So it's going to be the same. So the total area would be 54 square units. You don't have to add this in, but it's just good maths. adding them together. Was there not another possibility for area of a triangle? How? Half? Okay? Area rule with a sin in it. But what does that mean? It must be two sides and the included angle. That was an option, but it's longer. But let's just discuss it if you did want to go for it. If I didn't do the two separate ones, and I wanted to look at the big one, I have an inclination that that's maybe that they wanted me to do. If this was root 180, maybe we should just get this one, and then also the angle in between, or that one, distance, and the angle there in between. But angles I'm going to have to work out with what? What tree?
Inclination.
Is it an option? Definitely. So to find this distance here, finding two sides of the included angle, find this distance. Could you have done it with those two coordinates just like you did AB? Find the distance. But how would you find this angle? You have to work out inclination. If you got inclination, you can get straight line. Work out inclination, work out the opposite angles. Then you shorten the angle of the triangle to find the interior angles 180. And you could have done it that way. Do you see it's going to be more work? Because that inclination is going to be shift tan of 2 and then shift tan of a half. Get the actual angles, put it in here, and you'll have half of those two. It's lots more work. Distance formula, as well as two inclinations. Are you getting this? For sure, you'd get your 5 marks, but you did 10 marks worth of work. So sometimes just sit back a little bit and see which one can work. But if that's the only one that you saw, that's the one that you do. Happiness on that? That you can do it with the area rule as well.